Hello, and welcome to the Sleepy Physicist. I'm so glad you're here. Whether you're settling into bed, curling up on the couch, or simply trying to unwind after a long day of being wonderfully, exhaustingly human. This is our quiet corner of the internet, where science meets serenity, where complex ideas become gentle companions for your evening thoughts. Tonight, we're diving into something that happens to every single one of us, yet remains one of the most mysterious processes in all of neuroscience. Something so fundamental to your existence that you literally cannot survive without it. Yet so strange that it would sound like pure fantasy if we didn't experience it ourselves. We're exploring the hidden, sometimes disturbing reasons why your brain creates the wild, impossible worlds we call dreams. But here's what might unsettle you. Your brain doesn't dream for entertainment. It doesn't create these elaborate nighttime theatres for fun or creativity, though those are pleasant side effects. No, your brain dreams because it's performing a kind of biological maintenance so critical, so absolutely essential, that without it, you would quite literally begin to poison yourself from the inside out. I do hope this exploration isn't quite interesting enough to keep you fully awake, but if it does, well, at least you'll understand exactly why your brain will eventually demand that you sleep and dream, whether you want to or not. Before we begin this gentle journey into the night mind, if you find these slow science explorations helpful for relaxation or curiosity, I'd be grateful if you gave this video a quiet thumbs up and perhaps subscribe to join our growing community of sleepy scientists. And I'm always curious, where in the world are you listening from tonight? What time is it in your corner of the universe? Feel free to share in the comments below. Now take a comfortable position, let your breathing slow, and let's explore the beautiful, strange, and sometimes unsettling world that unfolds behind your closed eyes every single night. Every night, something remarkable happens to you. As consciousness fades and your body settles into stillness, your brain doesn't simply power down like a computer entering sleep mode. Instead, it begins one of the most complex, coordinated biological processes known to science. And at the centre of this process is something that would have seemed like magic to our ancestors, yet remains mysterious even to us today: the systematic creation of entirely fictional worlds, complete with characters, narratives, emotions, and sensory experiences so vivid they can feel more real than reality itself. You might think of dreams as random neural static, meaningless fireworks of a resting brain. But recent discoveries in neuroscience have revealed something far more intriguing and in some ways more disturbing. Your dreams aren't accidental. They're not the brain's screensaver. They're the result of a carefully orchestrated neurological process that serves a purpose so vital that evolution has preserved it across virtually every species that sleeps. Think about this for a moment. Sleep makes you incredibly vulnerable. For our ancestors, lying unconscious for 8 hours each night was an enormous risk. Predators could approach, threats could emerge, opportunities could pass by unnoticed. Yet despite this danger, every animal that's been studied, from tiny fruit flies to massive whales, engages in some form of sleep. This suggests that whatever happens during sleep, including dreaming, provides benefits so crucial that they outweigh the considerable risks of unconsciousness. But what could possibly be so important that your brain would shut down your connection to the outside world, paralyze your body, and create elaborate fictional experiences? The answer lies in a discovery that has revolutionized our understanding of why we sleep and dream. A discovery that reveals the somewhat unsettling truth about what your brain is really doing during those quiet nighttime hours. Picture your brain as a bustling city. During the day, this city is alive with activity. Billions of neurons are firing, processing information, making decisions, storing memories, and managing the countless functions that keep you alive and conscious. But like any busy city, this constant activity generates waste. Metabolic byproducts, damaged proteins, cellular debris, the molecular garbage that accumulates as a natural consequence of neural activity. In the rest of your body, the lymphatic system handles this cleanup, carrying away waste products and toxins through a network of vessels and nodes. But your brain is different. It's protected by the blood-brain barrier, a selective filter that keeps harmful substances out but also makes waste removal more challenging. For decades, scientists puzzled over how the brain managed to clean itself. The answer, when it was finally discovered, was both elegant and slightly disturbing. Enter the glymphatic system, discovered only in the last few decades and named for its dependence on glial cells, the brain support network. This system is your brain's overnight cleaning crew, but it operates according to a schedule that might surprise you. The glymphatic system becomes dramatically more active during sleep, increasing its waste clearance activity by up to 60% compared to waking hours. During the deeper stages of sleep, your brain cells actually shrink, creating larger spaces between them and allowing cerebrospinal fluid to flow more freely through brain tissue, washing away the day's accumulated molecular debris. But here's where it gets particularly interesting and perhaps a bit unsettling. Among the waste products being cleared during sleep are proteins that, if allowed to accumulate, become the hallmarks of neurodegenerative diseases. Amyloid beta plaques and tau tangles, the molecular signatures of Alzheimer's disease, are actively washed from your brain during sleep. Miss too much sleep, and these toxic proteins begin to build up, potentially setting the stage for cognitive decline decades later. This means that every night, your brain essentially performs a life or death maintenance routine. And dreams, those strange vivid experiences that feel so separate from biological necessity, occur precisely during the periods when this crucial cleanup is taking place. But the glymphatic system's nighttime cleaning routine doesn't always go smoothly. Sometimes the very process that's meant to protect your brain becomes the source of disturbing experiences. Consider what happens when this delicate system becomes disrupted, or when the boundary between sleep and waking consciousness becomes blurred. Sleep paralysis offers a particularly unsettling window into the brain's nighttime operations gone awry. During normal REM sleep, your brain naturally paralyzes your voluntary muscles to prevent you from acting out your dreams. It's a protective mechanism, keeping you from physically responding to the imaginary threats and adventures playing out in your sleeping mind. But sometimes, consciousness returns before this paralysis lifts, leaving you awake and aware, but completely unable to move. What makes sleep paralysis particularly disturbing is that it's often accompanied by hallucinations. People report sensing an evil presence in the room, seeing shadowy figures, feeling pressure on their chest, or hearing threatening voices. These experiences are so consistent across cultures and time periods that they have inspired countless legends of demons, ghosts, and supernatural attacks. The old hag of Anglo-Saxon folklore, the pinion of China, the se me subió el muerto of Mexico, all describe remarkably similar experiences of nocturnal paralysis and terrifying visions. But these aren't supernatural encounters. They're the result of your brain's normal dreaming mechanisms operating while you're partially awake. The visual and auditory hallucinations are dream content bleeding into waking consciousness. The sense of an evil presence likely stems from the activation of brain regions responsible for detecting threats, operating without the normal sensory input that would help distinguish real from imagined dangers. This reveals something profound and slightly troubling about the nature of consciousness itself. The boundary between dreaming and waking, between the real and the imagined, is far more fragile than we typically realize. Your brain is constantly constructing your experience of reality, and sometimes the construction process becomes visible, revealing the somewhat arbitrary nature of what we consider real versus imagined experience. To understand why dreams can be so bizarre, so emotionally intense, and sometimes so disturbing, we need to explore how the dreaming brain actually constructs these nighttime experiences. The process is far from random. It follows specific neurological patterns that reveal both the remarkable creativity of the human brain and some unsettling truths about the nature of consciousness itself. During REM sleep, when the most vivid dreams occur, your brain exhibits a fascinating pattern of activity. The visual cortex, responsible for processing sight, becomes highly active despite your eyes being closed and receiving no visual input. The emotional centers of the brain, particularly the amygdala, show increased activation, which explains why dreams often carry such strong emotional charges. Meanwhile, the prefrontal cortex, the brain region responsible for logical thinking, critical analysis, and reality testing, shows decreased activity. This neurological configuration creates the perfect storm for the strange characteristics we associate with dreams. Without the prefrontal cortex providing its usual reality checks, your dreaming mind accepts the impossible as perfectly normal. You can fly, breathe underwater, or find yourself in your childhood home talking to people who have been dead for years. And within the dream, none of this strikes you as odd. The decreased activity in regions responsible for logical thinking also explains why dream narratives can be so disjointed and why the passage of time in dreams feels so fluid. Your brain is essentially creating a story without a coherent plot structure, jumping between scenes, characters, and locations with a logic that makes sense only in the context of the dream itself. But perhaps most fascinating is how the dreaming brain handles memory. The hippocampus, crucial for forming new memories, shows complex patterns of activity during sleep. It replays experiences from recent days, but not in a simple, straightforward manner. Instead, it seems to be extracting emotional and associative elements from these experiences and recombining them in novel ways. This is why dreams often feel familiar, yet strange, populated by people you know in places that seem recognizable but aren't quite right. This process of memory consolidation during dreams serves an important function, but it also means that every night your brain is essentially remixing your experiences, emotions, and memories into new combinations. The result is a nightly parade of scenarios that can range from mundane to magnificent to genuinely disturbing, all created by your own mind using the raw materials of your lived experience. One of the most intriguing aspects of dreaming is how it handles emotions. Dreams aren't just visual experiences, they're emotional laboratories where your brain processes feelings, works through conflicts, and sometimes forces you to confront psychological material that you might prefer to avoid during waking hours. The emotional intensity of dreams comes partly from the fact that during REM sleep, your brain is flooded with acetylcholine, a neurotransmitter that enhances the vividness of experiences while simultaneously being depleted of norepinephrine, a chemical associated with stress and anxiety. This unique neurochemical environment allows your brain to revisit emotionally charged memories and experiences without the full stress response that would normally accompany them in waking life. This might explain why dreams often deal with themes of anxiety, fear, or unresolved conflicts. Your brain may be using the safe space of sleep to process difficult emotions and experiences, working through psychological material when the normal stress chemicals can't interfere with the processing. It's as if your brain has evolved a nightly therapy session, complete with vivid scenarios designed to help you work through emotional challenges. But this emotional processing doesn't always feel therapeutic in the moment. Nightmares, those particularly distressing dreams that can leave you waking in terror, represent this emotional processing system working overtime. Research suggests that people who experience trauma are more likely to have nightmares, as if the brain is repeatedly attempting to process experiences that are too overwhelming to handle during normal dreaming. The content of nightmares also reveals fascinating patterns. Across cultures and time periods, certain themes appear repeatedly: being chased, falling, being trapped, losing loved ones, or facing supernatural threats. These universal nightmare themes suggest that dreaming may tap into deep, evolutionary fears that helped our ancestors survive in dangerous environments. What's particularly unsettling is that the emotional impact of dreams can persist long after waking. A disturbing dream can colour your mood for hours, or even days, despite your rational understanding that it was just a dream. This suggests that your emotional brain doesn't always distinguish between dreamed and lived experiences when it comes to processing feelings and forming associations. As we drift deeper into this exploration of the dreaming mind, we begin to see that dreams are far from the random neural noise they were once thought to be. They're complex, purposeful processes that serve crucial functions for both your physical brain health and your emotional well-being. But they also reveal some uncomfortable truths about the nature of consciousness, reality, and the sometimes disturbing creativity of the human mind. We're only beginning to scratch the surface of why your brain creates these nightly journeys into impossible worlds. As we continue, we'll explore how modern life has begun to infiltrate our dreams in disturbing new ways, why some people become trapped in cycles of nightmarish experiences, and what the latest research reveals about the true purpose of these strange essential journeys into the depths of the sleeping mind. The story of dreams is the story of consciousness itself, and like consciousness, it's far stranger and more complex than it first appears. But perhaps that's what makes it so fascinating, and yes, sometimes so deeply unsettling. But there's something new happening in the landscape of human dreaming, something that would have been impossible just a few decades ago. For the first time in human history, our dreams are being invaded by technologies that didn't exist when our brains evolved their nighttime maintenance routines. And the implications are both fascinating and deeply troubling. Recent research has identified an entirely new category of nightmares: social media-related dreams. These aren't just dreams that happen to include phones or computers. They're nightmares specifically centered around the digital anxieties of modern life. People report dreaming of being unable to log into their social accounts, experiencing cyberbullying that feels viscerally real, or having their online identity stolen and manipulated by unknown forces. What makes this particularly unsettling is how these digital nightmares seem to tap into primal fears that are far older than the internet. The dream of being unable to access your social media accounts, for instance, mirrors ancient fears of social rejection and isolation. Your brain, trying to process the modern experience of digital connection, translates it into the emotional language of evolutionary survival. If you can't connect with your tribe, you're vulnerable, alone, potentially doomed. The blue light from screens adds another layer to this digital invasion of sleep. This light suppresses melatonin production, disrupting the natural circadian rhythms that regulate when and how deeply you sleep. But it's not just about delayed bedtimes. When your sleep cycles are disrupted, the timing and quality of your dreams change as well. You might experience more fragmented REM sleep, leading to dreams that feel incomplete or unusually intense. More concerning is how social media used during the day seems to bleed directly into dream content. People who spend significant time scrolling through feeds, consuming rapid-fire streams of information, often report dreams with similarly fragmented, rapidly shifting narratives. It's as if the brain's dreaming process is trying to make sense of the unnatural information diet of modern digital life, creating dreams that mirror the scattered, anxiety-inducing nature of endless scrolling. This digital contamination of dreams represents something unprecedented in human evolution. For millions of years, the content of dreams was drawn from direct physical experience, face-to-face social interactions, and the natural world. Now, a significant portion of our daily experience is mediated through screens, algorithms, and virtual interactions. Our brains, evolved for a world of immediate physical reality, are now trying to process and integrate experiences that have no direct analogue in the ancestral environments that shaped our neural architecture. Some people become caught in cycles of disturbing dreams that go far beyond the occasional bad dream. For them, sleep becomes a nightly confrontation with terror, and the bedroom transforms from a place of rest into a battlefield where they face their deepest fears again and again. Post-traumatic stress disorder creates one of the most severe disruptions to normal dreaming. Veterans returning from combat zones report nightmare frequencies that would be unimaginable to most people, sometimes several times per week, with content so vivid and terrifying that it can trigger full physiological stress responses. The dreaming brain, in its attempt to process traumatic experiences, essentially forces people to relive their worst moments repeatedly, each time with the full emotional and physical intensity of the original experience. What makes this particularly cruel is that the normal protective mechanisms of REM sleep become turned against the dreamer. Remember, REM sleep normally occurs in a brain free of norepinephrine, the stress chemical that would typically accompany frightening experiences. This chemical absence is supposed to allow for safe emotional processing, but in trauma-related nightmares, the content is so intensely disturbing that the brain's stress systems activate anyway, flooding the system with exactly the chemicals that REM sleep is designed to exclude. This creates a vicious cycle. The nightmares cause sleep avoidance as people become afraid to go to bed, knowing what awaits them. Sleep deprivation then leads to REM rebound. When you finally do sleep, your brain tries to make up for lost REM time by diving into even more intense dreaming periods. The result is nightmares that become progressively more vivid and disturbing, further reinforcing the cycle of sleep avoidance. But trauma-related nightmares reveal something profound about the purpose of dreaming. even when the process goes wrong, even when it becomes a source of suffering rather than healing, the brain continues its attempts to process difficult experiences through dream narratives. It's as if the brain believes so strongly in the importance of working through emotional material during sleep that it will persist even when the process becomes harmful. The consistency of nightmare content across different individuals also suggests something deeper at work. People who've never met, from different cultures and backgrounds, often report remarkably similar nightmare scenarios when dealing with similar types of trauma. This points to the possibility that certain dream patterns are hardwired into human neurology, ancient programs for processing danger and threat that activate when our modern experiences overwhelm our psychological resources. Perhaps one of the most unsettling aspects of dreaming is how convincingly real these fictional experiences can feel. This isn't just about vivid imagery or strong emotions, it's about the fundamental question of how we distinguish between real and imagined experiences, and why that distinction sometimes breaks down completely. False awakenings represent one of the most disturbing examples of this reality confusion. In these experiences, you dream that you've woken up and are going through your normal morning routine, showering, getting dressed, eating breakfast. Everything feels completely normal, completely real. Then you actually wake up and realize that your entire morning was imaginary. Some people report experiencing multiple false awakenings in a single night, creating nested layers of false reality that can leave them genuinely unsure about what's real even after they're fully awake. What makes false awakenings particularly unsettling is how they reveal the constructed nature of all conscious experience. During these dreams, your brain creates a perfect simulation of waking life, complete with appropriate lighting, familiar surroundings, and logical sequences of events. The simulation is so convincing that your conscious mind accepts it completely. This raises profound questions about the nature of normal waking consciousness. If your brain can create such convincing false realities during sleep, how can you be certain that your waking experience isn't also, in some sense, a construction? Neuroscientists have discovered that the brain regions responsible for monitoring reality and distinguishing between internal and external experiences show altered activity patterns during REM sleep. The prefrontal cortex, which normally helps you evaluate the plausibility of experiences and distinguish between memory and current perception, becomes less active. Meanwhile, the regions that generate sensory experiences become highly active, creating vivid perceptions without any external input. This neurological configuration explains why dreams can feel so real in the moment, but often seem obviously false once you're awake. During the dream, the parts of your brain responsible for reality testing are essentially offline. You experience vivid sensations and emotions, but without the normal cognitive processes that would flag these experiences as implausible or impossible. The implications extend beyond just understanding dreams. This research suggests that our normal sense of reality depends on a delicate balance of neural processes. When that balance is disrupted, whether by sleep, certain medications, mental health conditions, or neurological disorders, the boundary between real and imagined experiences can become frighteningly unclear. As we delve deeper into the mechanics of dreaming, we encounter perhaps the most profound implication of dream research: what it reveals about the nature of consciousness itself. Every night, your brain essentially constructs entire worlds, complete with physics, characters, narratives, and sensory experiences. And it does this without any external input, using only the raw materials of memory, emotion, and neural activity. This construction process isn't random or chaotic. Dreams follow certain patterns and rules, even if those rules differ from waking logic. Characters in dreams behave in ways that feel psychologically consistent, even if their actions would be impossible in the physical world. Dream environments often have a strange internal consistency, where impossible architectures or impossible physics operate according to their own dream logic. The hippocampus, that crucial memory center, plays a fascinating role in this construction process. During sleep, it doesn't simply replay memories like a video recorder. Instead, it seems to extract elements from different experiences and recombine them in novel ways. A childhood friend might appear in your current workplace, having a conversation about something that happened last week, in a building that combines features from several places you've lived. Your brain is essentially running a creative remixing process, taking the components of lived experience and building new scenarios. But here's what's particularly striking. People who have suffered damage to their hippocampus report dreams that are markedly different from typical dream experiences. Their dreams tend to be less detailed, less vivid, and contain fewer specific spatial and sensory elements. This suggests that the hippocampus isn't just involved in memory storage and retrieval, it's actively participating in the construction of dream experiences, using its memory networks to build the detailed, immersive worlds that characterize normal dreaming. This has profound implications for our understanding of consciousness. It suggests that even during waking hours, our experience of reality might be more constructed than we typically realize. The same neural networks that build dream worlds from memory and imagination might also be contributing to our waking experience, filling in gaps in perception, creating coherent narratives from fragmented sensory input, and constructing the seamless sense of continuous experience that we call consciousness. The evolutionary persistence of sleep and dreaming presents one of the most puzzling paradoxes in biology. From a survival perspective, sleep seems like an extraordinarily risky behavior. For our ancestors, spending 8 hours unconscious and immobile each night meant being vulnerable to predators, missing opportunities for food or shelter, and being unable to respond to environmental threats. The fact that every studied animal species engages in some form of sleep suggests that whatever benefits sleep provides must be absolutely crucial to survival. But the vulnerability extends beyond just physical danger. During REM sleep, your body becomes temporarily paralyzed, your temperature regulation is impaired, and your ability to respond to external stimuli is severely compromised. You're essentially as helpless as you ever are in your adult life. Evolution rarely preserves behaviors that create such extreme vulnerability unless the benefits are extraordinary. The glymphatic system provides part of the answer. The brain's waste clearance process is so essential that it's worth the risk of nightly vulnerability. Without this cellular housekeeping, toxic proteins would accumulate, leading to cognitive decline and eventually death. But dreaming adds another layer to the puzzle. Why not just have deep, dreamless sleep for maximum brain cleaning efficiency? Why did evolution preserve these elaborate, energy-intensive processes that create vivid, emotionally charged experiences? Recent research suggests that the answer lies in the integration of memory consolidation with emotional processing. Dreams don't just help clear metabolic waste from the brain, they help integrate daily experiences into long-term memory while processing the emotional significance of those experiences. This dual function may be so important for psychological health and adaptive behavior that it justifies the risks of prolonged unconsciousness. But there's something almost disturbing about this evolutionary calculation. It suggests that dreaming is so essential to human psychological function that natural selection has maintained a behavior that makes us extraordinarily vulnerable for a significant portion of our lives. Every night, you essentially trust your survival to the assumption that the benefits of dreaming outweigh the considerable risks of unconsciousness. This vulnerability paradox also reveals something about the modern world. Our ancestors' sleep was genuinely dangerous. They had to balance the need for rest against real threats from predators, environmental hazards, and human enemies. Today, most of us sleep in relative physical safety, but we've created new forms of sleep disruption that our evolutionary programming couldn't anticipate: artificial light, digital stimulation, irregular schedules, and chronic stress that can interfere with the natural sleep processes that our brains desperately need. We're in the strange position of being evolutionarily programmed for behaviors that made us vulnerable in the ancestral environment, while simultaneously living in a modern environment that disrupts those same essential behaviors. Our brains still need their nightly maintenance routines, but we've created a world that makes it increasingly difficult to achieve the deep, restorative sleep that those routines require. The result is a growing population of people walking through life with partially maintained brains, accumulating molecular waste, processing emotions incompletely, and integrating memories inefficiently. We've solved the external threats that made sleep dangerous for our ancestors, only to create internal threats to sleep quality that may be just as harmful to our long-term health and well-being. And as we'll explore next, the consequences of disrupting these ancient neural maintenance routines extend far beyond just feeling tired. They touch on some of the most fundamental aspects of what makes us human, and what happens when those processes begin to break down. As we drift deeper into the labyrinth of sleep science, we encounter perhaps the most chilling discovery of all. Your brain doesn't just clean itself during sleep, and it doesn't just process emotions through dreams. It also makes decisions about what you're allowed to remember and what must be forgotten forever. Every day, you accumulate thousands of experiences, conversations, sensations, and thoughts. If your brain tried to store all of this information with equal priority, you'd quickly become overwhelmed by an impossible flood of irrelevant details. So during sleep, particularly during the slow wave phases that precede REM dreaming, your brain engages in what researchers call synaptic downscaling, a process that sounds technical but is actually quite ruthless in its simplicity. Your brain essentially decides which memories deserve to survive and which should be allowed to fade into oblivion. The connections between neurons that represent important memories are strengthened, while connections representing trivial or redundant information are weakened or eliminated entirely. It's a nightly editing process, and you have no conscious control over it. But here's what makes this particularly unsettling. The criteria your brain uses to determine which memories are worth keeping aren't always what you might expect. Emotional intensity plays a major role. Memories associated with strong feelings, whether positive or negative, are more likely to be preserved. But so does repetition, recency, and perceived relevance to your survival and well-being. This means that every night, as you sleep peacefully, your brain is quietly erasing parts of your experience. That conversation with a stranger in the coffee shop, the exact details of what you had for lunch 3 days ago, the fleeting moment of beauty you noticed in a sunset. These experiences might be deemed insufficiently important and allowed to dissolve into the neural equivalent of white noise. What's particularly disturbing is that you'll never know what you've lost. The memories that get erased during sleep don't leave gaps or empty spaces in your consciousness. They simply cease to exist, as if they never happened at all. You wake up each morning with a slightly edited version of your life story, curated by neural processes operating entirely below the threshold of awareness. Research has shown that people who are sleep deprived show impaired memory consolidation, but they also show altered patterns of memory selection. When your brain doesn't get adequate time for its nightly editing process, it may make poor decisions about which memories to preserve. Important information might be lost while trivial details are retained, leading to the foggy, disorganized feeling that accompanies chronic sleep deprivation. But memory consolidation is only part of what happens during the strange hours of REM sleep. Your brain is also running what neuroscientists call predictive processing, essentially creating models of possible future scenarios based on past experiences. Dreams, in this view, aren't just random neural activity or even simple emotional processing, they're rehearsals. Think about the common dream experience of being chased. From a predictive processing perspective, this isn't just your brain recycling old fears or anxieties. It's your brain practicing escape responses, running simulations of dangerous situations, and testing different strategies for survival. The emotional intensity of the dream helps ensure that these practice sessions create lasting neural pathways that could be activated in real threatening. Explains why dreams often feel so urgent situations. This and emotionally charged. Your brain is treating these simulations as if they were real training exercises, complete with the stress responses and decision-making processes that would be needed in actual dangerous situations. The paralysis of REM sleep prevents you from physically acting out these rehearsals, but your brain is running the full program nonetheless. Studies of people with different professions have found that their dreams often reflect the specific challenges and scenarios they face in their work. Surgeons dream of complex operations, pilots dream of emergency landings, and athletes dream of crucial competitions. It's as if the brain uses sleep time to run professional simulations, practicing responses to situations that might arise in waking life. But this predictive processing can sometimes go wrong, particularly when it's fed data from traumatic or highly stressful experiences. Post-traumatic nightmares might represent the brain's prediction engine stuck in a loop, repeatedly simulating threatening scenarios based on past trauma and unable to find satisfactory resolution strategies. The brain keeps running the same terrifying simulations, hoping to find a better outcome, but instead reinforcing the very fear responses it's trying to resolve. This reveals something profound about the relationship between dreaming and consciousness. Your waking experience isn't just shaped by what has happened to you, it's also shaped by what your sleeping brain thinks might happen to you. Every night, your brain is essentially writing alternative versions of your future, and these imagined scenarios influence your emotional responses, decision-making processes, and behavioural patterns in ways you may never consciously realise. What happens when this intricate system of nightly brain maintenance begins to fail? The consequences extend far beyond simple fatigue or grogginess. When the glymphatic system can't perform its cleaning functions adequately, when memory consolidation becomes impaired, when emotional processing gets disrupted, the effects ripple through every aspect of human experience in ways that are both subtle and profound. Sleep inertia represents one of the most immediate and dangerous consequences of disrupted sleep processes. This isn't just the grogginess you feel when you wake up earlier than usual. It's a state where your brain has awakened, but crucial cognitive and physiological processes are still operating at sleep levels. Studies have shown that people experiencing sleep inertia demonstrate reaction times and decision-making abilities comparable to being legally intoxicated. But the truly disturbing aspect of sleep inertia is that the people experiencing it often don't realise how impaired they are. Their brains tell them they're awake and alert, while objective measures show severe cognitive deficits. This creates a dangerous window where individuals might need to drive vehicles, make critical decisions, or respond to emergencies while their brains are essentially still partially asleep. The prefrontal cortex, responsible for executive function, logical reasoning, and impulse control, is particularly slow to come online after sleep. This means that even when other brain regions have awakened, the parts responsible for good judgment and rational decision-making may still be operating in a sleep-like state. The implications for safety, relationships, and decision-making are sobering. Chronic sleep disruption creates even more serious problems. When the glymphatic system can't perform its nightly cleaning functions effectively, toxic proteins begin to accumulate in the brain. Research has shown that even one night of sleep deprivation can increase levels of amyloid beta, the protein associated with Alzheimer's disease. Chronic sleep problems may literally accelerate brain aging and increase dementia risk through the failure of the brain's waste clearance system. But the psychological consequences may be equally serious. When emotional processing during REM sleep becomes disrupted, people often experience increased anxiety, depression, and emotional instability. The brain's nightly therapy sessions aren't happening properly, leading to an accumulation of unprocessed emotional material that can overwhelm waking consciousness. We live in an era that is uniquely hostile to the ancient sleep processes our brains desperately need. Our ancestors slept in sync with natural light cycles, in environments that were genuinely dark at night and gradually bright in the morning. They experienced physical fatigue from daily activities that naturally prepared their bodies for rest. Their minds processed relatively simple, direct experiences without the constant stimulation of digital media. Today, we're exposed to artificial light well into the evening hours, disrupting the production of melatonin and other sleep-promoting hormones. We consume caffeine late in the day, stimulating our nervous systems when they should be winding down. We lie in bed with glowing screens, feeding our brains rapidly changing visual stimuli when they should be preparing for the slow, rhythmic processes of sleep. Perhaps most significantly, we've created a culture that views sleep as optional, as time that could be better spent being productive or entertained. We've forgotten that sleep isn't rest from life. It's one of life's most essential processes. The idea that we can function optimally on minimal sleep, that we can somehow outsmart millions of years of evolution through willpower or stimulants, represents a fundamental misunderstanding of what the brain needs to maintain itself. The result is a population walking through life with partially maintained brains. We're accumulating cellular waste, processing emotions incompletely, consolidating memories inefficiently, and running on prediction engines that haven't been properly updated through adequate REM sleep. We wonder why anxiety disorders, depression, and cognitive difficulties seem to be increasing, while simultaneously creating lifestyles that systematically disrupt the very processes our brains use to maintain psychological health. Social media adds a particularly modern twist to this crisis. The content we consume during the day, rapid-fire streams of information, social comparisons, outrage cycles, artificial social interactions, provides our brains with material that our sleep processes were never designed to handle. We're asking neural systems that evolved to process direct, physical experiences to somehow make sense of the virtual mediated experiences that now dominate our waking hours. Amidst all these discussions of the brain's nighttime maintenance routines and the disturbing aspects of dreaming, there exists a phenomenon that seems to offer the possibility of conscious control over the dream experience. Lucid dreaming, the ability to become aware that you're dreaming while still remaining in the dream state, represents both a fascinating glimpse into the nature of consciousness and a potential gateway to even stranger experiences. People who achieve lucid dreaming often describe it as exhilarating. They can fly, explore impossible landscapes, interact with dream characters, with full awareness that the experience is imaginary, and even attempt to direct the dream narrative according to their conscious intentions. It seems like the ultimate freedom, a playground of consciousness, where the normal rules of physics and logic don't apply. But lucid dreaming also reveals some unsettling aspects of the relationship between consciousness and dream states. Many experienced lucid dreamers report that their attempts to control dream content are often unsuccessful. They might become aware that they're dreaming, but the dream continues to unfold according to its own internal logic, resistant to conscious manipulation. It's as if consciousness becomes a passenger in its own dream, aware but not in control. Even more disturbing are reports of what some researchers call false lucidity, dreams in which you believe you're lucid dreaming, but you're actually still fully immersed in the dream state. You might dream that you've become aware of dreaming and that you're controlling the dream, but wake up to realize that the entire lucid dreaming experience was itself part of the dream. This creates unsettling questions about the reliability of consciousness itself. If you can dream that you're awake within a dream, how can you be certain that what you consider waking consciousness isn't also a form of dream? Some experienced lucid dreamers report encounters with dream characters that seem to possess their own agency, responding to questions in ways that surprise the dreamer and providing information that the dreamer doesn't consciously know. These experiences challenge our understanding of where dream content comes from and whether consciousness during dreaming is as unified and coherent as it appears to be. Frederick Van Eden, the psychiatrist who coined the term lucid dream, wrote extensively about his own experiences with lucid dreaming in the early 1900s, but he also reported that his lucid dreams were often followed by what he called demon dreams, nightmares populated by hostile entities that seemed to actively resist his attempts at dream control. It's as if the unconscious mind pushed back against conscious intrusion into the dream space. As our understanding of sleep and dreaming continues to evolve, we're beginning to develop technologies that can monitor, analyze, and potentially influence these ancient processes. Sleep tracking devices can now monitor brainwaves, track REM cycles, and provide detailed analyses of sleep quality. Some experimental technologies can even detect when someone is entering REM sleep and provide audio or visual cues designed to trigger lucid dreaming. But these technological interventions raise profound questions about the wisdom of interfering with processes that have been refined by millions of years of evolution. If dreams serve crucial functions in memory consolidation, emotional processing, and predictive modelling, what happens when we start trying to control or optimize these processes? Are we enhancing natural brain function, or are we disrupting delicate systems that we don't fully understand? Research into targeted dream incubation, the ability to influence dream content through sensory cues delivered during sleep, shows promising results for treating nightmares and processing trauma. By providing specific sounds, scents, or even gentle electrical stimulation during REM sleep, researchers have been able to guide dream content in more positive directions. This could offer hope for people trapped in cycles of disturbing dreams, but the same technologies could potentially be used for less benign purposes. If external cues can influence dream content, could they also be used to implant false memories, manipulate emotional responses, or even influence decision-making processes? The boundary between therapeutic intervention and mental manipulation could become uncomfortably thin. Perhaps more concerning is the possibility that our increasing reliance on technology for sleep monitoring and optimization might further disconnect us from our natural sleep rhythms. If we become dependent on devices to tell us when to sleep, how to sleep, and whether we've slept well, we might lose touch with the internal cues and natural rhythms that have guided human sleep for millennia. The modern world has already disrupted many of the environmental and social cues that historically regulated human sleep patterns. Adding technological intervention to this mix could either help restore healthy sleep or create new forms of disruption that we're not yet equipped to understand. All of this research into sleep and dreaming ultimately leads us to one of the most profound questions in neuroscience and philosophy. What is consciousness, and how does it arise from the activity of neurons? Dreams offer a unique window into this mystery because they represent consciousness operating without external sensory input, creating rich, detailed experiences from purely internal processes. During REM sleep, your brain generates visual experiences more vivid than many waking moments, emotional responses as intense as any you'll experience while awake, and narrative structures complex enough to feel like complete stories. And it does all of this while you're lying motionless with your eyes closed, receiving no input from the external world. This suggests that consciousness isn't simply a passive mirror reflecting reality. It's an active construction process that can operate independently of sensory experience. The fact that dream consciousness feels continuous and coherent, despite the bizarre and impossible events that occur in dreams, reveals something important about how consciousness works. Your brain is constantly creating a sense of unified experience from fragmentary inputs, filling in gaps, smoothing over inconsistencies, and constructing narratives that make sense of disparate elements. What we experience as the seamless flow of consciousness is actually the result of extensive behind-the-scenes editing and construction. Dreams also demonstrate the incredible creativity of consciousness. Every night, your brain essentially becomes a novelist, filmmaker, and set designer all at once, creating original stories, characters, and environments using only the raw materials of memory and imagination. The fact that these creations can surprise, delight, or terrify the dreamer suggests that consciousness has access to creative processes that operate below the threshold of awareness. But perhaps most intriguingly, dreams reveal that consciousness can exist in states that feel completely real, but are entirely internal. This raises profound questions about the nature of reality itself. If your brain can create convincing experiences of worlds that don't exist, how can you be certain that your waking experience corresponds to an external reality? The ancient philosophical question of whether life might be a dream takes on new dimensions when viewed through the lens of modern sleep research. As we near the end of our journey, through the strange world of sleep and dreams, it's worth reflecting on the profound circularity of these processes. You sleep to maintain the brain that will create tomorrow's experiences. You dream to process today's experiences so they can inform tomorrow's decisions. The memories you form while awake are edited and integrated while you sleep, creating the foundation for future memories. Every night, you essentially die a small death. Your consciousness fades, your connection to the external world is severed, and your body becomes temporarily helpless. Yet this apparent death is actually a form of rebirth. You wake up each morning with a brain that has been cleaned, memories that have been organized, and emotions that have been processed. You're literally not the same person you were when you went to sleep. This nightly cycle of dissolution and renewal has been happening every day of your life since birth, and it will continue until death finally makes the process permanent. In a very real sense, you've been practicing dying and being reborn every single day, though you're usually too unconscious to notice the transition. The universality of this experience, shared by virtually every human being who has ever lived, creates a strange kind of solidarity. Despite all our differences in culture, belief, and experience, we all surrender to sleep each night. We all dream bizarre dreams we'll mostly forget. We all wake up slightly changed by processes we don't control and can't fully understand. There's something both humbling and comforting in this shared vulnerability. No matter how powerful, intelligent, or successful someone becomes, they still need to sleep. They still dream strange dreams. They still wake up with edited memories and cleaned neural pathways. Sleep is perhaps the most democratic of human experiences. It affects everyone equally, regardless of status or circumstance. Yet despite its universality, sleep remains profoundly mysterious. We've learned an enormous amount about the neurobiology of sleep and dreaming, but fundamental questions remain unanswered. Why did evolution create such elaborate dream experiences when simple unconsciousness might serve the brain's maintenance needs just as well? What is the relationship between the dreaming self and the waking self? How much of what we consider personality and identity is shaped by processes that occur while we're unconscious? As our exploration draws toward its close, we must confront an uncomfortable truth. The more we learn about sleep and dreaming, the more we realize how much of human experience occurs outside of conscious awareness or control. Your brain makes decisions about which memories to keep and which to discard. It constructs emotional responses based on dream scenarios you may never remember. It runs predictive models that influence your behavior in ways you'll never consciously recognize. This knowledge can be unsettling. We like to think of ourselves as the authors of our own experience, as conscious agents making deliberate decisions about our lives. But sleep research reveals that much of what shapes our thoughts, feelings, and behaviors happens in neural processes that operate entirely outside of consciousness. We're more like passengers in vehicles driven by unconscious processes than we might care to admit. Yet there's also something beautiful in this realization. The fact that your brain works so hard to maintain itself while you sleep, that it processes emotions and integrates memories and clears away cellular waste, all without requiring your attention or effort, reveals a kind of profound self-care built into the very structure of consciousness. Your brain loves you enough to take care of itself while you're not looking. The elaborate nature of dreams, with their rich sensory detail and emotional depth, suggests that even the brain's maintenance processes have a kind of artistry to them. Your brain doesn't just clean itself during sleep. It creates worlds, tells stories, and explores possibilities. Even unconscious neural maintenance has a creative, almost playful quality that speaks to the fundamental creativity of consciousness itself. Perhaps the most profound insight from sleep research is that consciousness isn't a single, unified thing, but rather a collection of processes that can be separated, disrupted, and recombined in various ways. The self you experience while awake is different from the self that dreams, which is different from the self that exists during deep sleep. Yet all of these selves are you, different facets of the same underlying neural system operating in different modes. This multiplicity of selfhood, revealed most clearly during sleep and dreaming, suggests that identity itself might be more fluid and constructed than we typically realize. Who you are might depend not just on your memories and experiences, but on which aspects of consciousness are currently active, which neural processes are online, and how your brain is currently integrating information from internal and external sources. As we reach the end of our exploration, we find ourselves confronting a paradox that lies at the heart of consciousness research. The more we learn about the brain, the more mysterious consciousness becomes. Every answer we discover about sleep and dreaming seems to generate new questions that are even more profound than the ones we started with. We now know that sleep involves elaborate cleaning processes, memory consolidation, emotional regulation, and predictive modeling. We understand some of the neural mechanisms that generate dreams and can even influence dream content through external stimulation. We can track brain waves, monitor sleep stages, and measure the effectiveness of the glymphatic system. Yet fundamental mysteries remain. Why do dreams feel so real when they're happening? What determines which aspects of experience become incorporated into dream narratives? How does the brain decide which memories are worth preserving and which should be forgotten? Why did evolution create such elaborate dream experiences rather than simpler forms of unconscious maintenance? Perhaps most mysteriously, we still don't understand the relationship between neural activity and subjective experience. We can observe brain patterns associated with dreaming, but we can't directly access the content of dreams or understand how electrical and chemical activity in neurons gives rise to the rich, subjective experience of consciousness. This mystery extends beyond sleep into all aspects of consciousness. We can map brain activity associated with thoughts and emotions, but we can't explain how neural firing patterns become the felt experience of having thoughts and emotions. The hard problem of consciousness, how subjective experience arises from objective neural processes, remains as puzzling as ever. Yet this mystery is part of what makes consciousness so fascinating. We are the universe becoming aware of itself, matter organized in such a way that it can contemplate its own existence. The fact that we can study our own sleep, analyze our own dreams, and wonder about the nature of our own consciousness represents one of the most remarkable achievements in the history of the cosmos. Sleep and dreaming remind us nightly that consciousness is stranger, more complex, and more wonderful than it appears on the surface. Every time you close your eyes and drift into sleep, you're participating in processes that are ancient beyond measure, yet still barely understood. You're experiencing states of consciousness that feel completely real, yet are entirely internal. You're undergoing maintenance procedures that are essential for life, yet operate completely outside your awareness or control. In the end, the disturbing reason your brain creates crazy dreams every night turns out to be not disturbing at all, but rather evidence of the profound care with which evolution has crafted the systems that maintain consciousness. Your dreams aren't random or meaningless. They're part of an intricate dance of neural processes that keep you healthy, help you learn and grow, and maintain the miracle of awareness itself. Tonight, when you close your eyes and feel consciousness beginning to fade, remember that you're not simply falling asleep. You're entering into one of the most complex and mysterious processes in the known universe. Your brain is about to begin its nightly work of cleaning, organizing, processing, and creating. It will construct worlds that exist nowhere but in the patterns of electrical activity flowing through your neurons. It will tell you stories using the language of sensation and emotion rather than words. And tomorrow morning, you'll wake up slightly different than you were today, with memories reorganized, emotions processed, and neural pathways cleaned and maintained by processes you'll never fully understand, but that work tirelessly on your behalf every single night. The next time you find yourself wondering about the deeper mysteries of existence, consider exploring how the universe itself seems to have built-in limits that prevent us from ever moving faster than light itself. It's a cosmic speed limit that reveals profound truths about the nature of reality, and it connects to everything we've discussed about the boundaries and constraints that govern consciousness. That story of universal limits and the shocking reason they exist awaits in our next exploration. Entropy and light speed, the shocking reason the universe has a speed limit. Until then, sleep well, dream deeply, and remember that in the darkness behind your closed eyes, some of the most remarkable processes in the universe are quietly working to maintain the miracle of your conscious experience. As consciousness returns each morning, you carry with you fragments of the night's strange theatre, perhaps a conversation with someone from your past, the feeling of flying, or the lingering unease of being chased through corridors that shift like living things. These dream remnants fade quickly, dissolved by the bright urgency of waking life, but they represent something profound. Your brain's nightly attempt to make sense of not just what has happened, but what might happen, what could happen, and what you fear might happen. The hippocampus, that seahorse-shaped structure deep within your temporal lobe, doesn't simply file away yesterday's experiences like a dutiful librarian. During sleep, it becomes something far more creative and unsettling, a storyteller with access to your entire life's archive, free to mix and match elements from different decades, different relationships, different versions of yourself. It pulls your third grade teacher from 1987 and places her in your current workplace, discussing a problem you're having with a friend you haven't seen in years, all while you're somehow back in the house where you lived as a teenager. This isn't random neural static. Research reveals that the hippocampus is running what neuroscientists call replay events, but these aren't simple recordings played back at normal speed. Instead, these memories are replayed at 20 times their normal rate, compressed and accelerated, allowing your brain to rapidly scan through vast amounts of stored experience, looking for patterns, connections, and potential solutions to current challenges. But here's where it becomes particularly fascinating and slightly unnerving. The hippocampus doesn't just replay actual memories, it creates entirely fictional scenarios using real people, places, and emotions as raw materials. It's running what-if simulations, exploring possibilities that never happened but might need to happen. That dream where you had an argument with your supervisor, your brain might be rehearsing conflict resolution strategies. The nightmare about being unprepared for an exam. Your mind could be processing anxiety about upcoming challenges in your life. What makes this even more remarkable is that these simulations can actually change your waking behavior and emotional responses. Studies have shown that people who dream about practicing a physical skill show measurable improvement in that skill the next day, even though they never physically practiced. Your brain is literally learning from experiences that never happened, integrating fictional scenarios into your behavioral repertoire as if they were real memories. This reveals something profound about the nature of memory itself. The distinction between what you've actually experienced and what your brain has imagined or simulated during sleep becomes blurred in the neural networks responsible for guiding your behavior. Your reactions to people and situations are shaped not just by what has actually happened to you, but by the countless fictional scenarios your sleeping brain has rehearsed. Perhaps nowhere is the brain's nighttime creativity more evident than in how dreams handle emotional processing. Your sleeping mind becomes an emotional archaeologist, digging through layers of feeling and experience, excavating buried concerns and unresolved conflicts that your waking consciousness might prefer to leave undisturbed. The amygdala, your brain's alarm system, shows heightened activity during REM sleep, but it's operating in a strange neurochemical environment. The usual stress hormones that would accompany intense emotions during waking hours are suppressed, creating a unique state where you can experience powerful feelings without the full physiological stress response. It's as if your brain has created a safe space for emotional exploration, a laboratory where intense feelings can be examined without the usual consequences. This emotional safety net allows dreams to tackle psychological material that might be too overwhelming to process while awake. The death of a loved one, relationship conflicts, career anxieties, existential fears, all of these can be explored and processed during sleep in symbolic, metaphorical forms that make them more manageable. You might dream of being in a house that's falling apart, which could represent feelings about stability in your life, or find yourself swimming against a powerful current, which might reflect your sense of struggling against circumstances beyond your control. But dreams don't just process individual emotions, they also seem to work on emotional patterns and themes that span years or even decades. People often report having variations of the same dream throughout their lives, with the basic emotional theme remaining constant while the details shift to reflect current circumstances. The childhood dream of being chased might evolve into adult dreams of being pursued by responsibilities, deadlines, or social obligations. The core emotional content, the feeling of being overwhelmed by something you can't escape, remains consistent while the symbolic representation adapts to different life stages. What's particularly intriguing is how dreams seem to specialize in processing negative emotions. While pleasant dreams certainly occur, research shows that negative emotions are overrepresented in dream content compared to waking life. Fear, anxiety, anger, and sadness appear in dreams far more frequently than they occur during typical waking hours. This suggests that one of the primary functions of dreaming might be emotional problem solving, working through difficult feelings and situations that require more processing than positive experiences. This emotional focus of dreams might explain why dream content often feels so urgent and important, even when the actual events are clearly impossible or absurd. Your brain is treating these emotional rehearsals as critically important work, investing them with the intensity needed to create lasting neural changes that could help you handle similar emotional challenges in waking life. Human beings are fundamentally social creatures, and this social nature extends deep into our dream lives. Dreams are populated with people, friends, family members, strangers, enemies, and mysterious figures who seem familiar yet unidentifiable. These dream characters aren't just passive props in your nighttime narratives. They're active participants in complex social scenarios that reveal how your brain processes relationships, social hierarchies, and interpersonal dynamics. What's remarkable is how realistic dream social interactions can feel. Dream conversations often have the natural flow and unpredictability of real social exchanges, with dream characters responding in ways that surprise the dreamer. This suggests that your brain has internalized incredibly sophisticated models of how different people think, speak, and behave. Models so detailed that they can generate convincing social interactions, even when those people aren't physically present. But dreams don't just replay social interactions you've already had. They create novel social scenarios that allow you to explore different aspects of relationships and social dynamics. You might dream of having a conversation with someone you've never actually spoken to at length, or find yourself in a social situation that combines elements from different relationships and contexts. These dream scenarios can provide insights into social dynamics that your conscious mind might miss. Research has shown that people who experience social isolation or relationship difficulties often have more frequent and intense social dreams, as if the brain is trying to compensate for missing social interaction through increased dream socialization. During the pandemic, many people reported having more vivid dreams featuring large groups of people, crowded spaces, and normal social interactions, possibly the brain's way of maintaining social neural pathways during a period of reduced real-world social contact. Dreams also seem to serve as a kind of social practice space, allowing you to rehearse interactions, explore different social roles, and work through relationship conflicts in a low-stakes environment. That dream where you finally told your difficult colleague exactly what you think of them, your brain might be exploring assertiveness strategies. The dream where you found yourself giving a speech to a large crowd, you could be processing feelings about visibility and social recognition. And so we arrive at the end of our gentle journey through the labyrinth of sleep, having explored the remarkable truth that your brain's nightly maintenance routine is far more elaborate and essential than we ever imagined. The disturbing reason your brain creates these vivid, impossible dreams isn't disturbing at all. It's a testament to the profound care evolution has invested in maintaining the miracle of consciousness itself. Your dreams aren't meaningless neural noise or random entertainment. They're the visible evidence of your brain's nightly work as cleaner, therapist, memory editor, emotional processor, and creative simulator all at once. Every strange narrative, every impossible scenario, every forgotten fragment represents your mind's tireless effort to keep you healthy, help you learn, and prepare you for whatever tomorrow might bring. Tonight, as you drift towards sleep, remember that you're not simply resting. You're about to participate in one of the most sophisticated biological processes in the known universe. Your brain will construct entire worlds from the raw materials of memory and emotion, tell you stories in the language of symbol and sensation, and quietly perform the cellular housekeeping that keeps consciousness possible. And tomorrow morning, you'll wake up subtly transformed, with memories reorganized, emotions processed, and neural pathways cleaned by processes you'll never fully understand, but that work with exquisite precision on your behalf every single night. Sweet dreams, fellow travelers in consciousness. May your brain's nightly theatre be both restful and revelatory,